Here we're looking at congruent triangles, and so the first thing that we need to do is define what congruent polygons are. So the definition of congruent polygons is two polygons are congruent if and only if their corresponding parts are congruent. So in other words, if we had two triangles maybe like ABC and JKL, and say that we knew A and L here are congruent, B and K and J and C. And say we knew a little bit more. So say we had these two triangles, and we know that they're congruent because their corresponding parts are congruent, and we know that their corresponding parts are congruent because the triangles themselves are congruent. So there's a few different things that we need to look at here. One of those is the corresponding sides. So what are our pairs of corresponding sides? So these are any sides that are congruent. So one of our sides would be AC. AC is congruent to JL. So they are corresponding sides. We have AB, right? AB has the double congruent sign. Which side in JKL has the double congruent side? It is KL or LK. And finally we have BC, which has 3 tick marks on the side, and the side that has 3 tick marks in our other triangle is JK. We should also talk about the corresponding angles. Now in a diagram like this, we can name angles just by their vertex, because there is only one angle that can be angle A. Right, so we have angle A is congruent to angle L. Right, they both have single arches in their corners or in their vertex, right? They're the same. We have angle B, which must be congruent to angle K. And I'm missing angle C. Angle C must be congruent to angle J. In case it's not coming through clear here, right? We've got our congruent sign in between each of these. So segment AC is congruent to segment JL. Angle A is congruent to angle A is congruent to angle L. oftentimes, even in the definition, I'll use that symbol because it's just easier and quicker. And it is a symbol we should know by now. It shouldn't be one that we look at and don't know what it means. All right, the last thing is we want to make a congruent statement. Now, a congruent statement is just stating what triangles are congruent. Now, there's a lot of different ways that we can do this correctly here. There are also a lot of ways that we could do it incorrectly. So we're going to start with a correct one here. One would be to say triangle ABC. Now, as long as you name a triangle on this first one, it's one of the two triangles, it's ABC, you're fine. So you could start with triangle CAB or BCA. We'll look at that in a moment. Specifically, if we start with ABC though, then there's an order that has to come for the second triangle. And contrary to what you would think from English class, it is not alphabetical, right? So I picked ABC kind of because it's alphabetical and it didn't matter. However, now it does. Angle A is first in the first triangle, so whatever part matches with angle A has to be first in the second triangle. Well, A matches with angle L, right? So L must come first, not J. B matches with K, and C matches with J. So saying triangle ABC is congruent to triangle LKJ is not the same thing as saying triangle ABC is congruent to triangle JKL, because in fact, triangle ABC and triangle JKL are not congruent, right? But ABC is congruent to LKJ. Now, as long as A and L are in the same spots, it doesn't matter if they're first, second, or third. So we could write this as triangle BAC. Now B matches with K, so K would come first, and we have KLJ. Again, notice B and K, in one of them they're both second, and the other one they're both first, right? So they're in the same spots in both of those two triangles. The same with A and L, right? A and L. In the first one they're both first, in the second one they're both second. So again, there's a number of ones that we can do, but note here that we cannot say ABC is congruent to JKL because that order matters, and so we would be saying that A and J are congruent. And from our diagram, we don't know that A and J are congruent. All right, the next important thing that we have is CPCTC. And if you're bored sometime, try to say that as fast as you can. CPCTC, CPCTC, CPCTC. Now, it is fun to say. I think it is. But it does mean something as well. And it relates to our definition of congruent polygons that we were just working on, but it only applies to triangles. So this says that the corresponding parts of congruent triangles are congruent. Now, hopefully we notice where that CPCTC comes from, right? Corresponding parts of congruent triangles are congruent. So CPCTC. Now, this allows us that when triangles are congruent, even if we don't have a diagram showing each of the parts, that we are able to say that the parts are congruent. So if I know that triangle ABC is congruent to triangle, let's go with FED, all I need is that statement, and I know that the corresponding parts are congruent, so that AB, the segment, must be congruent to the segment FE. And BC must be congruent to ED, and AC must be congruent to FD. All right, looking at the angles is a little bit more difficult, but if we want to keep it simple, we might say something just like angle A is congruent to angle F. I bet you can figure out the rest of these. Angle B is congruent to angle E, and angle C is congruent to angle D. Now again, as I mentioned before, there's also different ways we could write this. So if I wanted a different congruent statement that is also true, we could do triangle CAB is congruent to triangle, while C matches with D, A matches with F, and B matches with E, and it's also the one that's left. All right, so as I do this, I want you to think about what you think might be true. So if we had two triangles, and let's say that we knew that A, B, C, D, E, F, and let's say that we knew that this angle here is 40, and this angle is 40, and the angle here is how about 80, and this angle here is 80. What do we know about angles A and D? Well, the first thing that we want to remember is that the sum of the interior angles of a triangle is 180. So for angle A, 80 plus 40 is 120. We need 60 more to get that angle. And 80 and 40 is 120. This would need to be 60. Therefore, you might notice or should notice that angles A and D are congruent. This is the third angles theorem, which says if two angles of one triangle are congruent to two angles in a second triangle, then the third angles are congruent. All right, kind of the last thing that we have here is the properties of triangle congruence. And surprise, we have the reflexive property, the symmetric property, and the transitive property. And as long as we haven't forgotten what each of these are, these should be easy, right? Reflexive property, triangle is congruent to itself. Triangle ABC is congruent to triangle ABC. Symmetric, if triangle ABC is congruent to triangle DEF, then triangle DEF is congruent to triangle ABC. And transitive property, if triangle ABC is congruent to triangle DEF, and triangle DEF is congruent to triangle GHI, then triangle ABC is congruent to triangle GHI.